Orion's Voyage, a journey through the Artemis 2 project. How many of us heard the conspiracy that the moon landing was fake? Many, right? And somewhere in our subconscious, something in us believed the theory could be real. But NASA is not leaving any room for conspiracy theories anymore, as it's sending the first crewed mission to the moon since 1972's Apollo with the Artemis missions. And you will be part of every step of the flyby mission and bear witness for the next generations to come. The Artemis project is a three-stage mission, with the first stage, Artemis 1, consisting of testing the Orion module and the ICPS cryogenic propulsion stage around the moon. The Artemis project will progress to its second stage, Artemis 2, featuring several human crewed missions that will take place on board the Orion spacecraft by 2024. So far, no woman has had the opportunity to set foot on the moon. That is very close, thanks to the Artemis program, designed by the American Space Agency to bring humanity back to the moon, which is expected to take place between 2024 and 2025. And it is precisely because of the female presence during the next lunar mission that the program received its name, which refers to the Greek goddess of hunting, nature, and chastity, also considered to be the protective of women, children, and childbirth, who was the daughter of the king of the gods, Zeus, with the titan, Leto. However, this is not the only difference between Artemis's quests and those that bear the name of her twin, the god of the sun, music, arts, medicine, prophecy, and justice, Apollo. Let's see together what this Artemis mission is designed for and discover the fun differences between these two missions that differ in age by half a century. In this mission, the astronauts will prepare for the upcoming ones to establish a base on the moon. Mission Artemis 2 will be the second stage of the Artemis project, full of anticipation and excitement. According to the mission plan, the following will include 4 astronauts who will take a return trip to the moon in 2024 in the Orion spacecraft. The mission goal is to study the lunar environment, demonstrate new technologies, and build a sustainable presence on the moon. Do you remember the famous Armstrong, "One small step for man, one giant leap for mankind" quote? The Apollo mission was the first human mission to the moon, launched by NASA from 1969 to 1972. The goal of the mission was to send 3 astronauts to the moon, collect samples of the lunar surface, and complete a range of scientific experiments. These experiments included testing the effects of gravitational fields, studying the composition of the lunar surface, and conducting seismic measurements. The Artemis mission is NASA's successor to the Apollo mission, which aims to send the first ever crewed mission to the moon since 1972. This mission would include 4 astronauts who will travel around the moon, collecting data and deploying robotic landers. The goal of the mission is to study the lunar environment, demonstrate new technologies, and create a sustainable presence on the moon. The Apollo mission had a different purpose than the Artemis mission. While the Apollo mission was focused on exploring the lunar surface and gathering data, the Artemis mission is focused on establishing a sustained presence on the moon, building a base, and furthering human exploration to Mars and beyond. The crew capacity is also different, as the Apollo mission usually included 3 astronauts, while the Orion spacecraft will allow for 4 astronauts in the Artemis mission. At liftoff, the mission will follow the same protocol as the Artemis 1 mission, with the Space Launch System, SLS, propelling the Provisional Cryogenic Propulsion Stage, ICPS, and the Orion spacecraft with a 4-person crew. After reaching Earth's orbit, the SLS will separate and return to Earth, while the ICPS will use hydrogen and oxygen to propel the Orion spacecraft to the moon. Unlike the Artemis 1 mission, which relied on Earth's gravitational pull to reach the moon, ICPS will be the sole fuel source for Artemis 2, allowing for a more expedited journey that keeps the crew safely outside of the Van Allen belts and their high levels of radiation. To ensure the astronauts' protection from radiation and any impacts from small space objects, Orion will be covered with a double layer of aluminum and Kevlar, the same material used for the anti-water break Echo shawls. NASA engineers determined that 2 thin layers of protection offer more efficient defense than a single thick layer. In order to protect its astronauts from the potential risks associated with traveling through the Van Allen belts, the Orion spacecraft will be equipped with several layers of protection. The outermost layer of protection will be made up of an advanced EMF radiation shielding system that is designed to absorb high amounts of radiation. This shielding system will be augmented by an active magnetic shielding system, which will deflect any remaining radiation away from the astronauts. In addition, the spacecraft will also be fitted with a layer of ceramic plating, which will absorb the radiation before it has a chance to reach the astronauts. The Orion spacecraft shields its astronauts from the dangerous Van Allen belt's radiation by allowing them to traverse it in a maximum of 2 hours. This is possible because the spacecraft is driven by its inertial and gravitational pull force of the Moon and only needs to turn on its engines to make minor direction adjustments. Once the crew reaches the Moon, they will be able to study the lunar surface and explore its dark side with confidence. Despite all these precautions, some radioactive particles still manage to reach the astronauts' bodies. The radiation doses in these cases are mild, but if left to accumulate for long enough, they can cause cancer and other long-term health problems. In order to minimize the amount of radiation that the astronauts are exposed to, the mission team makes sure that the astronauts spend as little time as possible inside the Van Allen belts. NASA gleaned a tremendous amount of information from the Apollo missions. This invaluable knowledge has been applied to upcoming Artemis flights to enable a return to the Moon. It is said that Artemis is the epitome of Apollo's legacy, and those of us who were not alive to witness the first human to step foot on the Moon will have the chance to experience a live lunar landing. As we anticipate humanity's return to the lunar surface, we reflect upon the historic lunar landings that came before us, providing a path for future lunar exploration and inspiring the Artemis generation. We will take a look at some of the key distinctions between NASA's Apollo and Artemis programs. While there are some similarities, each program also offers its own unique characteristics. One key difference between the Orion and the Apollo Command modules is their differing crew capacities. The Apollo Command typically accommodated 3 astronauts, whereas the larger Orion spacecraft has the capacity to have an additional crew member, allowing for a total of 4 Artemis astronauts. To accommodate the extra astronaut, around 316 cubic feet of space was added to the spacecraft. The 1960s saw the United States and the Soviet Union engaging in a space race with one another, making the notion of reaching the Moon more of a political than a scientific endeavor. The epoch in which the Apollo missions were undergoing progress was also energetic, with 6 lunar landings occurring within a 4-year period, making it the star of the show. The Artemis missions are aiming to develop a more sustained presence on the Moon through extended-term missions and the construction of lunar bases and a space portal. They are striving to create a prolonged and consistent presence on the Moon through extended-term missions and the construction of lunar outposts and an orbital gateway. The Apollo astronauts certainly conducted thorough experiments and gathered valuable lunar samples, and the Artemis missions will build upon that research by focusing even more heavily on science investigations and exploration. We will also make it a priority to create a sustainable lunar economy in order to acquire the expertise and technologies necessary to facilitate longer space exploration, such as our mission to Mars and beyond. Compared to the single-flight computer of Apollo, Orion has 2 redundant flight computers running simultaneously. Each of them consists of 2 redundant computing modules, giving it a total of 4 redundant systems. Additionally, one of Orion's redundant computers is only 3/4 of the weight of the single onboard computer of Apollo. An Orion computer also has 128,000 times more memory and is 20,000 times faster. Unlike the Saturn V rocket, which had 3 floors, the Space Launch System is powered by the powerful central floor with 2 solid rocket boosters attached to the sides and the upper floor called the Interim Cryogenic Propulsion Stage, ICPS, which gives the capability of sending the Orion spacecraft to the Moon. The central stage is the tallest rocket component in the world to date and serves as the backbone of the launcher, supporting the weight of the payloads, the upper stage, and the Orion spacecraft. SLS produces 15% more thrust than Saturn V during takeoff and ascent. The Saturn V and SLS are assembled at the same place 50 years apart. On Saturn V, the instrument unit was the nerve center of the rocket, providing the navigation and attitude control system, telemetry, and environmental control. The Orion stage adapter is the final piece of the SLS before the Orion spacecraft is added to the top of the SLS. It housed secondary payloads during Artemis 1. The Orion spacecraft and its radiation shielding systems are designed to protect astronauts from radiation exposure as they traverse the Van Allen belt and explore the Moon's dark side. By combining several layers of shielding and limiting the time spent in the radiation zone, the mission team is confident that the astronauts will remain safe and healthy during the trip. As such, the Orion spacecraft will be a benchmark in space exploration and a strong example of how to safely traverse dangerous radiation zones. At the end of the mission, the two astronauts will return back to Earth in the Orion spacecraft. This will be a historic moment, as the first footprint on the Moon in nearly 50 years. Here's to wishing them all the best and a safe journey as they embark on this momentous journey. Cheers! That's all for this video. Thanks for watching. Don't forget to like and subscribe to follow up with all the exciting topics regarding astronomy.